So whoever heard of this this thin watch, the CST-01 watch? Nobody. So it was Kickstarter. You know what Kickstarter is, right? Crowdsource funding for your company, right? So there's a bunch of web links here you can go read if you want to read more about this. So their claim to fame was it was the world's thinnest watch. And they look pretty nice. It's kind of cool. It's flexible. You can clip it on. Okay. They secured $1 million in funding in 2013. And then they ran into some really serious manufacturing issues. About one half of the watches didn't work after manufacturing. So companies call this yield issue. We're not yielding our product from manufacturing at the rate we need or we want. We want our yield to be a lot higher. Seagate used to call this scrap. And there was a huge effort in, and when you're manufacturing 200 million units a year, 1% scrap is a lot of drives. You don't want to be producing products at that volume with a 1% defect rate. And so a huge amount of work was done to drive the scrap way down and added money to Seagate's bottom line. And they got the yield issues on their manufacturing lines down to what management deemed an acceptable failure level. But 50%? Whoa. Then, that wasn't bad enough. They discovered that they needed to find a new battery and build custom battery management circuit, and we're waiting longer on other parts as well. This is a summary from these links here. So not only were they having trouble yielding their part in volume, or whatever volume that was, they discovered that they had other issues. And schedule slips kept happening. They eventually declared bankruptcy and closed the doors. So lessons can be learned there. Yes?
Do you know if this was more of a technical issue or a management issue, or a little bit of both?
I think there's both of those going on. I think they probably had an aggressive schedule. They certainly didn't vet their or prove their manufacturing process very well. If they're only getting 50% working parts coming back from manufacturing, that should have been a big clue to them right there that we need to take a deeper look at this. I think they probably overcommitted to their investment, to their investors as well. They said, oh yeah, we're gonna, this is our schedule and this is when we're gonna enter mass production. And so the investment community, the investors are thinking, all right, this is when I'm gonna start to see some return on my investment. But missing the battery issue, what happened there? That was a technical oversight by the people. There was some chief engineer or architect that was responsible for the whole electrical design of that watch. How did that engineer miss these battery requirements and when they were supposed to be in production? So that's my take on, I think, what the lessons are learned here. So you need to have a vetted, reliable manufacturing process. Yes?
So what is a typical scrap percentage? Does that vary based on how much you're producing? So like, does it go down? I think you'd want something very small if it's, if you're mass producing something, or?
I think the percentage of scrap is inversely proportional to the volume, total volume. I think the higher the volume gets, the lower and lower you want that scrap percentage, because the numbers can get astronomical, right? And you're just throwing money away. And it probably varies depending on the sector that you're operating in. If it's a data center type product or something, might have different requirements than a consumer level product. I mean, the financials might be different, right? And so you might be able to tolerate a higher scrap rate in one environment versus another environment, or one market versus a different market.
Now is scrap dictated by manufacturer error, or is that the way someone designed something, or what causes scrap?
Well, I'm going to stick with what I know. I would have to go back and reread these articles again, but I suspect that the process of pressing and pushing all those components together, they probably came into some kind of a fixture where the components were pressed and snapped together, and that pressure ended up cracking solder balls and cracking traces and causing various mechanical problems. That's my theory, okay? So the manufacturing process can have issues with it. Did I tell you guys about the, yeah, I told you about the part that I worked at where the package, it was I can't remember if it was a leaded package or it was a ball grid array, but the die kept getting smaller and smaller and smaller. I told you guys about that. And then the balls started cracking when they did the thermal stressing on it. So these kind of things happen. That's why shock and vibration and thermal testing of your products is so important during the validation process. You want to find those before your customer finds those. So I'm not sure there's just a global, one answer fits all about what causes scrap. I was going to speculate on what Seagate's issue was, but that wasn't an area of my focus. There were manufacturing people that were highly focused on that. And I can't even imagine the logistics of bringing all that material together to generate. So you're doing, well, let's just make it even, 120 million units annual. So you're doing 10 million units a month. And that's 10 million cases and 10 million chips and 10 million, and how many resistors and how many capacitors. And I said, somebody's a logistic magician there.